Okay, in the previous week, we discussed about what machine learning is, what are the different types of machine learning, what are its classifications, and what are the challenges in machine learning. Now, this week, we will try a hands-on activity where we will try to train our, we will do a simple training on our, actually teach our machine how to predict a certain value. Now, this video, or rather this lecture, will be divided into two videos. So this is the first part, which will encompass more of discussion first on some concepts that we will be using when we actually do the actual learning demo. Now, for the outline here, so we will discuss about the machine learning workflow, how you actually do machine learning, and we will see some open access, semi-open access data sources, and we will also discuss our sample application, which we will be doing later in the next video, which is about California housing prices. Now, this application is basically based on the book by O'Reilly. So you have hands-on machine learning with scikit-learn and TensorFlow. So this is my reference for this activity. After doing the sample application, we will also discuss, or we will check out how do you gauge the performance of your prediction, or rather the performance of your machine. How well has it learned? How well is your system performing on your application? So we will try an evaluation, which is RMSE, root mean square error, and we will also discuss some training models that we will be using for this activity. The training models are not limited to this one, but these training models will be discussed because we will be using these training models in our sample application. So the training models are the linear regression, decision tree, and random forest. Now, for the pipeline or the machine learning workflow, so this is general workflow. So of course, at the start of any machine learning or even the data science workflow, the first is always knowing what the problem is. So we need to formulate our question. We first need to know what exactly are we looking for, and then we get our data. So of course, in machine learning, the data is essential because this is where or how we will teach our machine to do that. And after obtaining the data, of course, if you by experience, remember when we were doing downloading data from BigQuery, sometimes some of the data have null value. So sometimes, or rather most of the time, the data are messy. Sometimes it's not purely numerical. So there are some categorical data, and we cannot use categorical data when we are doing numerical calculations, of course. Now, of course, so after obtaining the data, the next step is to get your feel of the data. So know what the data is about. So know the basic descriptions, or what data that we have. Do we have empty or null space? Do we have numerical data only? Do we have a mix of numerical or categorical data? Or even do we have an image data? And then once we have an idea of what data we are going to work on, of course, we need to prepare that data to clean it up, remove the unwanted, because remember, the machine learning, how well our machine learning will perform, or how well the training will turn out to be, is highly dependent on, of course, the data that we will feed it to. So if your data is not really very good, of course, the outcome model will not be good as well. Now, after preparing the data, you need to select your model. So what are the models that we have? So we can, as I said, we have several training models that we will be doing in this activity, which will be the regression models, the linear regression, the decision trees, and the random forest. And then we train the data using we train the model using our data. And then after training them, you evaluate them. So you usually have a test. So the initial data that we retrieved, we will divide it into two. So we have your test data and the training data. So the training data will be used for, of course, training our model, but the test data will be used for evaluating our model. How well is our model performing in predicting the outcome of our test data? And depending on the results of the evaluation, we can fine-tune our model. So actually, fine-tuning and then retraining our model if it's good or bad. Anyway, after fine-tuning the model, once we are satisfied with the performance of our model, we can now present it. So if you are doing a project, so you create a presentation for your solution and or launch, monitor, and maintain your system if it will be continuously used. For example, it is being used in certain in the industry in your company. For example, in the future, once you have graduated, so you are doing data science analytics, so you which will be used continuously. So you monitor and maintain your system. So basically, that's the general workflow of your machine learning. So where will we get the data? So these are some open access data source, although Google Cloud is not exactly open access. So we have Google Cloud. If you want to learn more on machine learning and do more data science analytics, actually I advise you to go to Kaggle. Kaggle.com is basically a repository of many databases, as well as it's actually a social hub for data scientists. So they also issued challenges on some problems that you can practice your data science or machine learning skills on. We have Amazon AWS datasets, the data portals, Open Data Monitor, and QuantDL. So these are also some sources of open access data. And of course, if you work in the industry, the institutional data, the company data can also be used as a data source. So this is our sample application, which is the application that we'll be working on in the next video in our hands-on activity is predicting housing prices in California. So this is the state of California divided into districts. So we will need to create a model that can predict how much the prices of the houses should be tagged on. So this is not the consumer here, or rather the client here is not the buyer of the house, but rather the investors or the sellers. Actually, it is actually the first step in machine learning. So we need to know, this is our problem. We want to know the housing prices in the state of California. So our client here is the real estate developer, and first of all, we need to frame the problem. So we want to predict the median housing prices in the state of California because, of course, for real estate developers, you want to actually create, or rather, of course, you need to develop housing that will be bought. For example, if you create or you build houses in a very good district and you peg it a very high price, but the people that want to move into that district are poor and cannot afford the housing, so it will all come to nothing. So you will have a flop investment. So you want to create the prices of the housing, whereas you will get the optimum sales as well as the optimum price, the optimum profit. So basically, you cannot price it too high if your buyers are cannot afford it, or you cannot price it at too low. Otherwise, your buyer will think that area or that region will be problematic. So again, they really won't buy any house from you. So basically, that's the idea for knowing the actual or the optimum real estate price for a certain region. Actually, you will be encountering this not only here, not only in the state of California, but also even here locally in the Philippines. So if you, for example, the housing prices in Manila and Quezon City are very high as opposed to the other parts of the country, which is, say, in the provinces of, say, Bulacan or even in Laguna. So the prices of housing and even land and house and lot is always larger in more developed areas as opposed to the less developed ones. And not only the development is the effect, but also, for example, the geography of the region. If the region, for example, here I'm in Valenzuela, so our district here is prone to floods. So you have, of course, the regions or the areas that are prone to flooding are of course priced lower than those regions that do not really stay, that usually are not flooded. And for example, Valenzuela housing prices versus Manila housing prices. Of course, Manila housing prices will be higher because they are more located in city centers. There are lots of commercial buildings located there, as opposed to here in Valenzuela, where this is more industrialized. There are many factories here actually, so it's usually less, and we don't have that much commercial buildings at the moment. So anyway, so those are some considerations, and it's quite difficult actually to create an actual equation to compute housing prices based on just what do you call this, those parameters, because there might be some hidden effects or hidden factors that we cannot know. So we want to use machine learning to do that. So leave all of the thinking to the machine, so just teach them using the data that you have. So anyway, so that's our strategy for approaching this problem. So here is your the workflow of our problem. So we have our data, we obtain the data, and then our component will be used to at least estimate a good housing price for that district. So this data will be used for investment analysis of the real estate developers and their investors. So after framing the problem, so remember the workflow, the next one is get the data. So we will get, after we get the data, actually later on in the hands-on video, we will see that. So knowing the data, we need to decide on what machine learning approach we will have. So our data here is, our given data is actually a labeled data. So these are some of the questions that you need to answer. So what data that we have? So the data that we will have is a labeled data. So later you will see it. So it's basically tables, and you actually know what, for example, it's a column, table column. So it's a typical labeled data. So what type of machine learning is it? So since we have labeled data, so the best approach will be doing supervised learning. We can actually still do reinforced learning, but since the data that we have is just we have a limited data source, it's not that large, so it's just better to stick with the simple one, so supervised learning. And what do you want to accomplish? So our problem is we want to know what would be the appropriate housing prices. So what will be the appropriate housing price? That is basically a predictive approach. So we want to know what will be the best. So we want to predict what would be the best prices for the housing. So this is a prediction. So since this is a prediction type of problem, so the best way to do this is actually do a linear regression, or make a regression analysis. So this is a regression problem. So do we have data being updated continuously? No. So we just download the data once. So this data is not continuously updated. So no. Therefore, another one is the data very large. No, it's not very large. It's actually around 2,000 rows. So it's not really not really large data. So this is still a no. So since the data is not updated continuously and it's not a large data, we can comfortably use batch learning here. So if you remember batch learning, we will just be teaching our machine one time, and that's that. So we have a one-time big time teaching for the data, since we do not have a large data and it's not really being updated. So that's our approach for machine learning. Now once we have trained the model, we need to know how well is the model performing. So since this is a regression problem, this is a regression analysis, one of the usually used performance evaluator for a regression analysis is the root mean square error. So why do we need to have a performance measure? Of course, we can train and create models, but how well do we know that this model will be accurate? So we need to know if our system is accurate in actually predicting model prices. And how will we measure its performance? Is basically, one of them is to use RMSE. And the RMSE is RMSE is basically, this is not the only performance measure in machine learning, but this one is typically used for regression. So this one is actually appropriate for our sample or our application. So in RMSE, it's just, since this is a regression analysis, so here is a regression line. So it just measures how far the actual data is from your model, which is the regression line here. So this is your RMSE. Now, what are the training models that we will be using? So we can use, since this is a regression analysis, we can have several choices to have. So we can have linear regression. So we have a simple linear regression. So if our simple linear regression, it's only dependent on one independent variable and one dependent variable. For a multiple linear regression, you have more than one variable. So here in the picture is a multiple linear regression. So you can actually visualize it in a plane, or rather as a plane. So you have 3D space here. So anyway, linear regression is just, in basic algebra, this is your line, x and y line. So y is your dependent variable, x is your independent variable. So we can just create an equation of the line. So basically that's linear regression. And another one is decision tree. So decision tree can be both used for classification or regression. So basically this is answering a series of questions, and depending on your answer, you will be directed to the next question, so on and so forth, until you reach your classification or you reach a decision. So we have here the initial condition. So it's made up of several terms or parts of the tree. So you have the root of the tree, the very first initial condition or the very first question. And then from the very first question, it will branch out into, well, basically the edges. It will branch out to other nodes, which are your internal nodes, or if it ends, or the branch ends with a classification or already a decision, so that becomes the leaf or the decision. So here is an example of your decision tree. So this is a decision tree that can predict whether the applicant in a work applicant will accept the offer or not. So the first question will be, is the salary enough? So if it's yes, if it's enough for that applicant, so if it's between 5,000 to, so if it answers yes, the next question will be, is the office near your home? So you can also, sometimes some people can also use this to decide whether they should accept the offer or not. So what is the salary grade? Is the workplace near your home? So if it's yes, do you have your cab facility? So whether you accept or decline your offer. So here in decision tree, you can see that the best, or rather the most important, or rather the root, the initial condition, is a very significant is a very significant in decision trees, such that your decision tree, your root, must be able to, because this is the first question. So for example, if the first question is the office near your home, this condition, or rather if the first question cannot accurately divide the samples or your data into its proper location, because again this will branch out, you will actually the decision tree will become inaccurate. So long story short, the root of the decision tree is important in the accuracy of your decision tree. So the next one is the random forest. Random forest, as its name suggests, a forest is made up of trees. So this is a set of decision trees, because decision trees again is vulnerable to outlying data, and of course the first question, the initial condition, is very important in your decision tree, especially in accuracy. So we have a random forest to make up for those inadequacies of your decision tree. So as a random forest is basically a collection of decision trees. So they are different decision trees. We will be running the data into these decision trees, and the final decision will be the tally of your decision tree. So this offers more flexibility than actual decision trees. So for example, you have here your decision trees. So this is a random forest algorithm. You have a set of 9 decision trees. So you run your data, the same data in all of these decision trees. So this, computationally speaking, this takes quite a longer time than doing a simple decision tree or even a linear regression. And depending on the outcome of all the decision trees, so you will tally them. Will the answer be 1 or 0? So the one here, the outcome is 6 ones and 3 zeros. So the prediction will be based on what is the most, or basically it's a vote. It's a popular vote. So which has the most or the greatest score. So that will be your prediction. So that's it for the first part of our hands-on lecture. So in the next part, we will be doing the actual machine learning. So for the next part, before I forget, please see the video I posted on creating a virtual environment. So we will be using, it's actually in doing machine learning, it's good to create your own virtual environment so that you have your own separate bubble for your system. Okay, so that's it for this for the first part. So see you in the next part of the lecture for the demo.